Video is to go over homework packet 5C. So let's do lesson 5.09, problem number 5. It says segment OZ is the bisector of angle QOR. Prove that segment QP is congruent to segment PR. So we got to prove that segment QP is congruent to segment PR. What's given? Well, hypercube, sorry, PR. So what's given is we have a circle, we have a center O, we have Q, and we have R, and we have angle QR, and we have angle bisector OZ, and we have chord QR, intersection we call P. So what's given is that we know that angle OZ bisects QOR. That means angle QOP is congruent to angle ROP. So QOP is congruent to ROP. So these guys are congruent. Okay. So in order to show that, our goal is to show that so QP is congruent to PR. So first thing I want you to see is two triangles. Two triangles QOP and ROP. So first thing you want to do to prove the goal is to show that triangle QOP is congruent to triangle ROP by using one of those TCP, triangle congruence postulate. That could be SSS, SAS, ASA/AAS. So use one of those to show that these two triangles are congruent. Then you can say segment QP is congruent to segment PR by CPCTC. So those are the hints for the problem. Let's go to lesson 5.10, which is on the 4th page of the packet, and let's work on problem number 13. So it says given measurement angle AB is 30 degrees and measurement angle CD is 60 degrees. And our goal is to find measurement angle APB. So let's draw a circle, and well, you already have one, right? So you have a diameter AD because it hits the center of the circle. Now you have B to C, and we have OC, and intersection is P. What we know is chord CD is 30 degrees, and a chord AB is 30 degrees. Oh, wait a minute, this is 60 degrees, sorry, 60 degrees. Okay, the key here is to understand the relationship between central angles in the chord, arc measures, right? So for the central angles in the arc measures are congruent. So if the angle measures 60 degrees, then angle COD is 60 degrees, right? Don't get confused by, this angle right there, APB, is not the central angle because the intersection is not on the center. So be careful with that. The key here is to draw chord AC like this. Now you can see that angle ACB right there is a inscribed angle of AB. And we know that inscribed angle angles are half of arc measure. Okay, our goal is to find this guy, right? And also, if you look at the other way, if you look at angle CAD, that is inscribed angle of arc CD, right? Now, if you look at this, and if you look at do you see the triangle PAC, right? You have three angles inside that must add up to 180, and this guy must add up to 180 as well. So you can, those are the hints to find the answers for problem number 13 in lesson 5.10. Next problem. It's on the next page, which is on lesson 5.11, problem number 7. So it says, calculate all missing angle measures and arc measures in the diagram. So those are the hints. Those are the goals, right? Okay. And the givens are, we have a circle, and we have points M, point J, point K, points L, and you have a quadrilateral inside. This special quadrilateral, we call it cyclic quadrilateral. And we have arc measure MJ is 100 degrees, right? And we have 68 degrees here and 79 degrees. These are the hints. Use the fact that inscribed angles, I'm just going to put IA, is half of the arc length, arc measure. Okay, use that fact, number one. Another thing you can use is that theorem 5.12, which is that the opposite angles of cyclic quadrilateral, so for example, in this case, it's this guy and this guy right here. Those two angles must add up to 180. Likewise, this guy right here, angle J, and 79 degrees, angle L, must add up to 180 degrees. So those are some hints. Also, I want you to look at arc JKL, right? That's the arc. Where is the inscribed angle of it, right? So you can find that by using fact A. So that's 5.11. So let's go to 5.12, which is on, I don't know, I lost which page, but it says 5.12. And let's do problem number 6. So it says, in a circle with center O, OP is 1 inch and measurement angle POQ is 30 degrees and angle PQ is tangent to the circle. Find OQ and PQ. So we need to find OQ and PQ. Alright, let's look at what the givens are. So we have O here, P here, and you have tangent line, which means just touching, right, to the point and to the circle, and you have Q here. Okay, and what's given are OP is 1 inch, and angle OPQ is 90 degrees. So, and also POQ for here is 30 degrees. Okay, and then find OQ and find PQ. Do you see that this is a special triangle, which is half of equilateral triangles, right? Because so this is O. Why do I write Q. OPQ. So if you make another copy and flip it over, that's going to be equilateral triangle. So that tells you that, well, what we know is OQ is, OP is 1, right? We know that PQ, we do have a special relationship, right, for that. What we have is, for 30, 60, 90 degrees triangle, we know that the short leg is half of hypotenuse, right? Right. So whatever this is, the hypotenuse should be twice as big, right? And the height of the other leg is square root of 3 times longer than that. So you can use that fact. So so 1 times some number is, well, wait a minute. So I'm sorry. So those are the relationships. So we know that relationship between P and a Q. Once you find a P, that's going to be, OQ will be twice as long as PQ. But we know that the PQ is, well, actually OP is square root of 3 times as long as PQ, right? And we know what the PQ is. No, wait a minute. We know what the OP is. OP is 1, and a PQ is square root of 3 times as long. Oh, no, wait a minute. I'm sorry. So we know, I'm sorry, OP is, yeah, that's right. OP is, sorry. So OP is square root of 3 times as long as PQ, and we know OP is 1. So you can solve this equation, let x be q, and solve this equation. And for x, do some math to find x, then you get whatever. Whatever you get, you multiply by 2. That's going to be OQ. So that's 512. Let's do one more, which is 513. Lesson 513, problem number 7. So two chords, segment AB and segment CD, through a point P inside a circle, measured 7 centimeters and 13 centimeters respectively. If AP equals 3 centimeter, find PB, CB, FB. So those are the goals. So let's draw givens. Givens are, we have circles, we have segment AB, we have segments CD, and it says through a point P inside a circle. Oh, so sorry. So we have a circle, and AB and CD through P, so that means it's intersecting like this, and the point is P. And inside a circle, measured 7 centimeters. So these are congruents. So AB equals 7 centimeters, CD equals CD. So AB is 7 centimeter, CD equals 13 centimeters. And then we know AP is 3. AP is 3, so this is 3 from here to here, here to here. Right? Find PB, which is easy because we know what the AB is, so we know what that should be, right? And then we have to find a CP and a CD. So we just found we know that we learned that the power of points. So P is the power of points. Has a special relationship, right? So that says AP times PB is, oh, wait a minute, what page is that? It has, well, let me just find a special relationship, right? So AP times PB should be equal to that's going to be the power of points. P, that should be equal to CP times PD. So PB should be 4. So AP times PB equals AP is 3 and PP is 4. And we have to find out CD and PD. I mean CP and PD. So we have to find out some number CP and some other number PD, right? That's going to have to be multiplied to 12. But those numbers, CD, right? CD is CP plus PD. So CP plus PD has to be 13. Okay? So that number, whatever this number is, plus this number has to be add up to 13. So you have to find out the number that adds up to 13 and multiply to 2, I mean multiply to 12. That's going to give you CP and PD.